Hey guys, before I start this video, I want to give a special shout out to one of my buddies. He just recently got a job at Old McDonald's Farm. He's the new CIEIO. Shout out to you all. Hope you enjoy the video.
Come on now, dog. Come on, man.
What's going on, Stat Cats? It's Mr. C here. Shout out to you all. In this video, we're going to do another section of guided notes, but I have something special that I formatted it with. So we'll see how it goes, and hopefully you get some good takeaways from it. And let's start things out with a Jigsaw learning activity. Okay, here we go. So this is what I'm going to present to you guys right now. Is not specifically tailored to the section of notes. However, the bones of this essentially is the structure of this. Basically, I'm just going to explain what a jigsaw activity or how jigsaw activity could work. So I first started doing this learning activity in my college algebra course a number of years ago, and I based it on speed dating 4 types of equations. And I usually, when I form groups in my classes, I usually do 4 groups because we have 8 tables. So 4 rows of tables on one side, 4 rows of tables on the other side. So it's just easier for me to group them up in 4 groups. And how I do it is I'll start on one end of the classroom and just count off by 4s until everybody has been given a number. And prior to them getting all together, where they're originally sitting is their original group. And once they get their number, I give them some time to move around the classroom to join up with everybody else that has their same number. And then we proceed with the rest of the activity. All right, so yeah, I love this meme. Speed dating to find true love, but speed dating to learn math. Boom, boom, boom. All right, so the learning activity overview. So the Jigsaw method is basically a way to get your classroom a little interactive, and it's also a great icebreaker if students haven't introduced themselves to each other yet. I find that this is like the kernel of those budding friendships that can happen inside the college classroom. So it's really cool to see the students getting closer with each other as time goes by after doing an activity like this. So what this activity was designed to do, like I mentioned, 4 groups. One group was assigned the quadratic equation, another was assigned the radical, absolute value, and then factorable. And there was a handout that I created with 4 QR codes, which gave what I was making like dating profiles for each of these types of equations. And once they were in their groups, they had to take some notes on the videos that were embedded within the dating profile and also work on some practice problems. So I find that you can probably at a minimum get by with doing this complete activity in an hour. At least that was the goal. But depending on like side conversations and questions, I'll be honest with you, it could go up to an hour and a half. So just be aware of that. Okay, so here's how my classroom is usually set up. The teacher station is in this corner of the room, and I'm usually on the left-hand side of the projector screen facing out towards the students. And as you can see, starting in the top row, I might begin in this corner and say, hey, you're a person 1, then I point to this person, they're a person 2, then 3, then 4, then back to 1, then back to 2, then 3, then 4, then down to 1, 2, 3, 4, and so on and so forth. As a heads up, the activity can still be successful even if some tables are missing students because they're absent, or maybe you don't have a full class. So I can address those details at a later time if need be. But what I'll usually do is I'll have anybody that was assigned the number 1 group at these 2 rows of tables. And then back here would be anybody assigned a 2. And over here, anybody assigned a 3, and then anybody assigned a 4. And it's at this stage that they work on their group activity. So it looks like I assigned group 1 quadratics, group 2 radical, group 3 absolute value, and group 4 factorable. So I won't get into too much of this, but this is like a cover sheet for the activity. Once they're in their assigned groups, they do some function book stalking. That's kind of a play on Facebook. And like I mentioned, there's some QR codes which takes them to an equation dating profile. And within the dating profile, they watch some embedded videos and take notes about that particular type of equation. And then they go on a first date. This is where they practice problems in their numbered group. And then what I'll do after some time has passed, and it's usually about, I'll give 20 to 25 minutes to do this. Sometimes it's quicker, sometimes it takes longer, so you just kind of have to have a feel for the audience. But once they've finished their first date packets, I check to make sure all groups have finished it, or depending on time, I'll have them move back to their original seats, and then basically what they do is they swap information with each other. So going back a couple of slides, see if I can do this. So they work on their practice problems in their designated group. And theoretically, what should happen is when they come back together to their original seats, person 1 should have information to share with person 2 and person 3 and person 4. Person 2 should have information that they could share with person 1, 3, and 4. Person 3 can share their information with 1, 2, and 4, and then person 4 will share their information for 1, 2, and 3. And by the end of the activity, everybody has essentially gained exposure to all 4 types of equations. So that's kind of a quick intro to how I at least run a Jigsaw activity. So I thought, with this next section in the textbook, again, it's Elementary Statistics by Mario Triola, the 14th edition. I'm not getting paid to say that. And by the way, fair use. This is for teaching and commentary purposes. Shout out to the Coach Gang and the Money Mindset crew. So let me kind of take you through the process of how things panned out for me. And I'll let you know it's not fully complete because it takes a while to build this sort of activity. But thankfully, I've done this activity enough times where I can kind of make some quick decisions about what to include, what to exclude, and so on and so forth. Okay. So what I first did is I went to Claude just to see how Claude would organize the information in this particular section. And let me show you that section. Begins on page 62. Let's see if that's correct on the website. Yeah, so section 2.3 is on graphs that enlighten and graphs that deceive. Ooh. All right, so I'll just quickly skim through this section. So in this section, there's a variety, kind of like a junkyard of popular graphs that are used to display data. And these data can be based on frequency distributions, it could be time series analysis, and what have you. And they open up with dot plots. Then they phase into an example. And then the next one is a stem plot. So just some basic information here. An example, and then a time series graph. An example, then bar graphs, Pareto charts, an example of each, pie charts, an example of a pie chart. This cracked me up. Pie chart that speaks for itself. People who enjoy making pie charts, this little sliver, and then people who wish this was real pie. Yeah, I mean, that sounds lovely. Frequency polygon. Then relative frequency polygons, 6, 7. And then graphs that deceive. So mention about a non-zero vertical axis and also disproportionate pictographs. So right here, shout out to the NSA right there. And I believe that is the tail end of the section. Let me just confirm. Okay, concluding thoughts. This is actually a pretty good game right here. I enjoyed this part of it. And then it looks like they're showing how to, well, not how to, but what types of software can create, different subset of graphs in this section. Long story short, there's a lot of different information that, if you were doing this in an ordinary fashion of giving notes, that's a lot of pivoting that you have to do. And so you're going to have to activate different areas of their brains, and it could be exhausting not only for them, but for you as well. And this was actually what inspired me to do a jigsaw activity for the college algebra course, is that, all right, I have a lot of information that if I do this in my personal traditional way of giving notes, it's going to take forever. And when you teach college, for those of you that do, you already know that you start out with negative time to work with in order to get through your curriculum. So you have to kind of, walk a thin line between getting everything in, but also making sure you stick to your schedule. So that can be a challenge. So I thought, all right, well, what would be a good way to sort of have the student shoulder the burden of all this learning, but being there to facilitate their learning, but also increase the engagement, and I don't know, just to kind of spice it up a little bit. Students find this a little bit awkward at first, but at the end of the semester when I ask for their feedback, this is one of their favorite activities to do. So if you're nervous to deploy it in your class, I totally understand, but I would encourage you to do so if possible, because it can be fun for everybody. And you'll be putting the fun in functions if you do this in algebra class. All right, so going back to Claude, I wanted to see how Claude would assign the different types of graphs to the 4 different groups. And it says here, Jigsaw activity structure. So this is a quick debriefing of how Jigsaw works. You'll work in 2 phases. In phase 1, you meet with your expert group and study 1 graph type in depth. In phase 2, you regroup, so each new group has 1 expert from every original group, and you teach each other. This is the key right here. You teach each other. All right, as you're probably aware, you know that you know something really well if you're able to teach it. Now, granted, this might be their first time ever experiencing or encountering any of these types of graphs, and that's okay. That's to be expected. But this is going to be a good personal challenge for each of them, which will, force them to hopefully learn the material better. So that's another benefit of this. Okay, so Claude is given 15 minutes for people to organize in their expert groups. I might give 20. And then Jigsaw group, so this is when they go back to their original seats. I might give 20 for that as well. And then a whole class debrief, if you have time for that. So it says each group shares 1 surprising finding. Instructor connects the Enlighten versus Deceive theme. So this is a good synopsis of it, but as you'll see, mine's slightly different. Okay, so I asked Claude to, I said, greetings, I'm feeling inspired to create a Jigsaw learning activity for section 2.3, graphs that enlighten and graphs that deceive, I should say. Blah, blah, blah. It says Jigsaw activity works beautifully for this section. And I think Claude or any AI is going to, gas you up a little bit. So just know going into your initial prompts for any of these AI platforms that you got to just exercise things with a grain of salt. Okay. So it says here, the expert group cards, which I didn't make cards. This is really just the initial way of organizing the material for each particular group. So group 1, or group A, in terms of Claude, is bar charts and Pareto charts. Group B, time series graphs. Group C, dot plots and stem and leaf plots. And then group D, misleading graphs. So I said, excellent start. If you could create worksheets for each group, that would be great. I would like there to be an area where they fill in information about the following elements: definition, advantages, disadvantages, and an example that they can work on. These examples can come from, that should have said, the examples can come from you or from the textbook. Okay, so I actually had to go back and forth with Claude a little bit, and I'll show you one of the versions of a worksheet that Claude produced for me. And this is a group that I fully finished their expert worksheet for. So I based my worksheet that I'm going to use on what Claude provided here. As you'll see, I sliced and diced it up and kind of reorganized things and all that. But this gives you a good starting point. So Claude gave a section overview by basically giving away the definitions of deceptive graphs, so on and so forth. It came up with some pretty decent looking diagrams and some follow-up questions, key concepts in your own words using Triola page 82 through 88, which is an error, by the way. Okay, so make sure you vet the stuff that AI gives you. So created an area for definition, advantages and disadvantages, and I personally thought that this was giving too much away. This is all information that I would actually like the students to figure out on their own, so you'll see what I did with that. And then key features and how to identify. So, enough there to where students can build good dialogue and good talking points with each other. And of course, I looked at the examples that they gave me, and they were decent. I tweaked them a little bit. So the first data set it gave me was for monthly sales in thousands of dollars. And Claude is challenging them to create two bar charts, one in which the y-axis goes from 0 to 100,000. That's what Claude is considering an honest bar chart. And then a bar chart where the y-axis goes from 78,000 to 92,000. So Claude is trying to have students create a side-by-side analysis of two graphs, one in which is true and honest, and the other one in which is deceptive. So it gives tasks, sketch graph 1, honest y-axis, so on and so forth. And then I kind of like this, in 2 to 3 sentences, how does the visual impression of sales growth differ between the two graphs, even though the data is identical? So the thing you might know about deceptive graphs is they're there to basically create shock and sway feelings and opinions about things. Then it says list the other 3 deceptive techniques from section 2.3. So I really didn't like the fact that it was, number one, giving me the wrong page numbers, which that's okay. I mean, you're responsible for making sure the information's accurate anyway. But also there was a lot of reference, Triola says this, based on Triola's this and that. So, it was just a little bit too formal, which you can't blame it. It's a literal software. Gave an area to show your work. And then this part is really good, although I'm not going to use it, okay, because I have something else in mind for it. These are always good questions to ask, whether it's for a statistics class or an algebra class. What pattern or trend does your graph reveal? How could this graph be made misleading without changing any data values? And critical thinking. This is more specific to deceptive graphs. And then I like this part too, where it says prepare to teach. And so this part right here is towards the end of the group work. And what I want students to think about is how they would present their findings to the other 3 groups, okay? This isn't necessary, but interesting if you have time. One thing that surprised me or I found interesting. And then some objectives here. So fairly decent. It might be a little too much for, the time constraint. But if you want to roll with it, go for it. So here's how I change things up, just based on my experience and the students' needs. All right, so clearly I changed some of the font and did a little editing here, included the name area. And I had it create a different display of charts for me. So pie charts and 4 deceptive techniques, Triola section 2.3. So it leads off with the pie chart, which is an honest representation of some data. Gives some hints as to what to expect. These are slices that are proportional to relative frequency and all slices sum up to 100%. And then they give a different looking version of a pie chart, which can be a little deceptive. So going back to the original document Claude gave me, Claude totally missed the pie chart subsection of 2.3. So that was an issue. I went back and I said, hey, you missed the pie charts. Can you incorporate the pie charts into one of the worksheets that you create? So it did, but it actually added it to a different group's topics. And I realized that the first group, group 1, had a disproportionate amount more of work that they would be required to do versus the other 3. So essentially, I had Claude merge the pie chart stuff into this section, or this group, which would be group 4, by the way. So group 4, expert worksheet. So this is when all the people that were assigned to number 4 come together to work on this particular packet. This is where the learning happens. So they can fill this out collectively, or if you have like some students that are relatively introverted and want to fill it out on their own, that's fine too. It's really up to the consensus of the group. I've had some sections of college algebra where the group members like to work individually and then check their work with each other. But then I've had other groups that were completely social and sometimes had to get them back on track to complete the packet. So just be aware of that and adjust accordingly. So this is the reason why the graphic looks a little bit different than what Claude provided originally. So I felt that there was some good information here, and I edited this part. It had definition, and then it went to advantages and disadvantages. So remember, this is supposed to address Group 4's challenge is to learn about pie charts and graphs that deceive. So I went a little more straightforward with the table, and I just figured I'd have them lead off with definitions of a pie chart and a deceptive graph. So it says here, what is a pie chart? What does each slice represent? What must all slices sum to? And to help them out with this information, I'm going to be handing out printed copies of the section from the textbook. Where's that at? So I'm going to print off this entire section and give a packet to each student so that they don't have to share copies. And the reason why, it's not that I'm against them sharing, it's I want them all to have the resource when they leave the classroom. So as they read through that content, they should be looking out for this information that they can use for an answer. And a definition for deceptive graphs. What is a deceptive graph, and what are 2 main ways a graph can be drawn to mislead people? So one thing that you want to be careful about is doing copy and paste stuff. So it's really easy to just copy and paste instructions. But I don't really think this is all that earth-shattering, but just make sure you go back and edit some things. It's a little more professional looking, and it if you do some copy and paste errors, the students might think that you're trying to be a little bit lazy, which I'm guilty of, no doubt. So I also want them to find an example within the reading. It says provide a sketch of the pie chart from the textbook reading, and in your own words, this is key, describe what the pie chart is trying to convey. So I'm hoping there's enough space for them to do that. If not, these are going to be single-sided copies so they can show their work on the backside if they need more room. And then I follow it up with an example of a deceptive graph. Provide a sketch of a deceptive graph from the textbook reading. After I just got done saying all that stuff about anyway. Okay, provide a sketch of a deceptive graph from the textbook reading. In your own words, describe why the graph is deceptive. So I'm really trying to have them think critically about what they're reading and not just look for the information and copy it down. So some of this stuff is not going to be from that section reading, and that's the whole point. I want them to be able to synthesize it in their brains and then figure out a way to convey what they're learning to people that are not in the know. And one thing that this is building behind the scenes is if there are any potential statisticians in the course or people that might need to present data at a company that they're working for, this will help them get the practice they need in order to home in on that skill. Okay, because a big part of statistics is not just the number crunching, but it's also interpreting and communicating the information in an accurate and honest way. And as you can see, I stuck with the advantages and disadvantages idea from Claude, which actually was my idea to begin with, but I removed all of this and might just keep this as a key. So these are things that I'm hoping will pop out to them in the section reading, and if they don't catch it all, that's fine. I just want them to at least find 2 advantages of using a pie chart to represent data. And quite honestly, I'm okay if they go on the internet to look up this information, as long as they have it and it's correct. And also 2 disadvantages of using a pie chart. There really, in my opinion, is not an analogous thing for deceptive graphs. So I had to come up with something different, but still around the same rigor. And so I created a row for real world. And here I actually am encouraging them to go online. It says perform a Google search to find any event in history in which a deceptive graph was used to deceive the public. Write a 2 to 3 sentence summary of your findings. And to be honest with you, I should probably have them include the website that they got this from. So I'll kind of think about that some more. I just hate writing down long URLs. So I'll just kind of trust that the information is based on a legit Google search. So I thought that was kind of a creative thing to put in there. Again, just digging deep into Bloom's taxonomy stuff. There's some teacher jargon for y'all. And then I kind of edited the format and instructions for the practice problems that they gave. I stuck with their example of favorite cafeteria foods, which theirs looked a little more blasé, and it's actually not in this version of it. I think the cafeteria food might be in like version 3 or 4. So anyway, somewhere along my chat with Claude, it gave me a version with an example involving cafeteria foods, and it says survey results, favorite school lunch option, 200 students surveyed. So we got pizza, pasta, salad, sandwiches, and other. And the end value is 200. So I'm going to be guiding and facilitating all this. Drawing a pie chart is not the world's easiest thing to do, but I would like to see what they're able to accomplish on that regard. And I will let you know I do plan on showing them how to create a pie chart using technology, either StatDisk. Actually, I don't think StatDisk does that, but Excel at least, or Google Sheets. So the tasks for them are to calculate the relative frequency for each lunch option. That's a great review question. And construct a properly labeled 2D pie chart with each slice's percentage shown. So you're probably going to need to help them with this because the way that it demonstrates how to do this in the textbook is actually based on angles that are calculated. And so they'll have to, know how to properly sketch out an angle. And so there's going to be a little bit of help that you probably have to provide for this part. And then show all the work in the space below. All right, so I gave them a good amount of space to do all their scratch work and official solution with. And I actually didn't really like the, well, maybe I lied. I like the idea of the example that Claude gave for the deceptive graphs, but it didn't really give way to the type of spirit in which I want them to pick up on with the idea of a deceptive graph. So Claude's example was, okay, see if you can take this data and draw it in an honest way and a deceptive way, which is fine and dandy, but I wanted to do a little bit more with that. Something that's a little more, not cerebral, but something that, what's the word for it? Something that gives more context to one of the issues with deceptive graphs. So self-driving cars, and this is actually an example from the textbook, says in a survey of adults, subjects were asked if they felt comfortable being in a self-driving vehicle. The accompanying graph depicts the results, which is based on TE connectivity. That's where the data comes from. And this is a screen clipping of one of the problems from the back of this section's problem set. And this is what I'm trying to get out of this example. All right, describe how the graph is deceptive. Reconstruct the graph to be more honest. So this will really hit home on the fact that you should, for the most part, always have a y-axis that starts at 0. And then explain how the honest graph might be more telling of the subject's responses. So the idea there is that this looks like a dramatic difference between the yeses and nos. But would it be as dramatic if you started the y-axis at 0 versus 200? And it may or may not be. So I'm interested to see what they come up with. In most cases, it should tone down the drama, but it might not. So, just kind of all depends. And then show all the work in the space below. I don't think I'll really need to do much hand-holding for this type of problem, at least not nearly as much as that for the favorite cafeteria foods. But so, once they're finished with problem 1 and 2, I want them to start thinking about how they're going to report their findings to their peers in the original groups. So what I did is, again, with the help of Claude, I had it kind of give me the bare bones of kind of like a note-taking handout, and titled like Jigsaw Listening Notes, which I'm fine with that title. And I kind of sliced and diced it up. And so going back to this PowerPoint, so this is when they're in their expert groups. And like I said, once time is up or all groups have finished their work, whichever comes first, they're going to get back into their original groups. And so person 1, or from group 1, is going to be presenting their findings to people that were in groups 2, 3, and 4. And I would like them to take some notes on that. So these are kind of like mini presentations, and this will really help to close up and tie up loose ends with the learning portion of the Jigsaw activity. And then it'll be, group 2's turn, group 3's turn, and then group 4's turn. And let's imagine that group 4 is presenting their findings on pie charts and graphs that deceive. So what's going to happen is each person is going to have a copy of this handout. And let's say that a person from group 1 is listening. Then as the member from group 4 is presenting, they're going to be filling out this area of the handout. So pie charts and graphs that deceive. So as a person for group 4 is presenting their information, they're going to be responsible for jotting down, the definition of a pie chart. And also what makes a graph deceptive. I'd also like them to copy down any relevant sketches from the presenting expert. So, if the expert included a diagram in their definition, then this would be a good spot to place it. And then I want them to copy down the solution I'll say to at least one of the experts' practice problems. And ideally, I'd like them to copy down both practice problems, but I'm, just kind of trying to be cognizant of time. So it'll be their opportunity to pick which one. And if they run out of space, they can write on the backside of this, but, copy down the solution to at least one of the experts' practice problems. And I would really like them to ask questions along the way. It reinforces the learning on both ends, so both the presenter and the listener. And like I said, use the backside of the sheet if you need more space. So that's what's going to happen when anybody from Group 4 is presenting to people from Group 1, 2, or 3. If you're interested in knowing what Group 1's topics are, it's bar charts and Pareto charts. I still have to work out their expert group worksheet. And then Group B is time series graphs. I got to make their worksheet still. And then Group C is dot plots and stem and leaf plots. All right, so that should actually say Group 2 and Group 3. There we go. Okay. So what would really close this thing out is printing off just a small set of practice problems that everybody at their designated table from the original seats can work on together. And I still have to put something together on that front, but this is really all I have for now. And that's where I'm going to stop the video. I figured I'd just kind of give you the general structure of a jigsaw activity and how you can adapt it to knocking out a section of notes that has a lot of different types of information in it. So hopefully you find that all helpful. Of course, if you have any questions, let me know. And if you want any of these handouts for this PowerPoint, feel free to, let me know in the comments. But be sure to hit the like button, subscribe, ring the bell for notifications and all that stuff. And I want to thank you all for watching. And let's continue to boss up. And I appreciate you, Stat Cats. Have a great one.